Hello, class 12th physics, current electricity, important question continuing from previous video. Plot of variation potential difference across a combination of three identical cells in series versus current is as shown in the figure. What is the EMF of each cell? So first of all, E net of the combination is equal to 6 volt. That is when current is 0. When current is 0, that is open circuit condition, then the voltage measured is the measure of EMF. Now there are three cells, so E net is 3E equal to 6, so E equal to 2 volt. Next, a wire of resistance R is bent in the form of a circle. Find resistance of across diameter. Here, if it is bent into two parts, then both the parts will be halved. So R1 is equal to 4R now, and R2 is equal to 4R now. This is R1, this is R2. So their resultant will be R1, R2 are in parallel combination. So 1 upon R1, which is 4R plus 4R. Well, this year, this series parallel is not included in the syllabus, but still I am doing it because some other way it can be asked. So don't trust fully on CBSE. So R12 is equal to 2R. Still such type of question, they can bend this question in any other form, and then they can ask. So it is better to do such kind of simple question here. Just avoid studying theory of this series parallel of resistance. Why terminal voltage of cell is less than EMF? So we can explain it with the help of this equation. So therefore V is always less than E. That's all. And if you want to write theoretical answer, then the answer will be, because some of the current cell has to deliver through its electrolyte. So some potential drops inside it. That is why terminal potential difference is lesser. Can terminal voltage be greater than EMF? So the answer is, when it is connected to some external source. As below. Like there is a cell and there is another source whose positive end is here and negative end is here. So that is during charging. V is greater than E. But it is not due to cell itself, but due to some external source. But only during charging of cell, we apply this voltage. This is, we apply this voltage, and that must be greater than the EMF. So, but in ordinary condition, while discharging of cell, when cell is being used, then voltage can never be greater than EMF. Define mobility, and hence explain why electrons has greater mobility than hole. This question belongs to semiconductors, but I have included these questions here. So what is mobility? I'll begin with its formula. Drift velocity per unit electric field. So we can define mobility of a charge carrier is its drift velocity per unit electric field. That's all. And okay, So we know that Vd is E tau upon m upon E. So it is now E tau upon m. Now mass of electron is less than mass of hole. Actually, more a hole does not have any mass, but hole is a whole assembly. Um, if you could remember, just go to that semiconductor chapter, and there we have said that hole is a vacancy. So that vacancy includes that region of surrounded by um, some neighboring atoms and all that. So entire that assembly is considered as mass of that charge carrier. So it is a hypothetical concept of whole, assumption of whole, but still if that exists, if because there are some neighboring atoms, and then there is a vacancy created there. So as a whole we consider all of that assembly as part of whole. That is why it is considered as heavy. So principle of Witterstone bridge, principle of meter bridge, principle of potentiometer. So I am directly writing them and then I will explain. So here it is. See, actually this should be explained. This arrangement should be explained. So that is why without this you can't write this expression. In Wheatstone bridge arrangement as given in the figure, um, this figure, if galvanometer shows no deflection, then P by Q equal to R by S. This is Wheatstone bridge principle. Now, state the principle of Wheatstone bridge. It is based upon the principle of Wheatstone bridge. You should write it in full. I'm just asserting its name. That is why I'm writing it in short. So don't use such short forms in the exam. All right. So according to which, so here you have to state that Wheatstone bridge principle also. State principle of, actually they haven't asked that name the principle of Wheatstone bridge. Then it is Wheatstone bridge principle. They have said state the principle of Wheatstone meter bridge. So it is based upon Wheatstone bridge, and then you have to restate all of it here. I'm not going to write it again, but that's all. This is what it is all about. Now potentiometer. So first, I'll do some work here. V equal to IR, we know, and V equal to I in the place of R, rho L upon A. So V equal to V proportional to L. But when will be it directly proportional? When I and A remain same. So keep this thing in your mind. So potentiometer principle. Potential drop. Actually, we have to use word potential drop. How much potential it has dropped. Potential drop across any portion of conductor is directly proportional to length of that portion, provided constant current and area of cross section. That's all. This is what this entire thing explains. V equal to I rho upon A multiplied by L. So V is directly proportional to L. When? Only when I and A are constant. So all that things. So two metallic wires of same material have same length, but cross-sectional area in the ratio 1 is to 2. They are connected in series, in parallel. So first in series. In series, I will same. I1 is equal to I2. Current will be same. And we know I equal to V na. So VD1 Same material, so n will also be same. A1 is equal to VD2. So VD1 by VD2 is equal to A2 by A1. But A1 by A2 is 1 is to 2. So A2 by A1 is 2 is to 1. That is 2. 2 upon 1. So 2 is to 1. So now in parallel, voltage across them is same. So V equal to IR. Now I1 R1 is equal to I2 R2. So okay, now again the same process. This time this I is not that I, so we can't say. So I'm putting a prime over here so that you will not get confused about that. So VD1, which we have to find in terms of ratio, En A1, and for R, rho L upon A, rho. Actually, we can write its microscopic form also, ml upon tau E square Na, but not required. This is, and now I2, VD2 ENA2 and rho L upon A2. Length is same, so that is why I have written LL in both sides. Now everything is going to be cancelled out. So VD1 is equal to VD2. So VD1 by VD2 is equal to 1 is to 1. That's all. Bye bye.